Hi, my name is Alexis Reifsteck, and today we're going to be talking about Justicia americana, or water willow, and if it is a driver or a passenger in its Ozark Stream ecosystem. So one of the coolest things about water willow is that it grows by rhizomes. And in other ecoregions, it's known to increase the stream bed stability and increase habitat structure, which is really cool. So we want to know if it does the same thing in Ozark streams and if it can be termed an ecosystem engineer, but we'll get more on that later. So another thing to note is that water willow is the first macrophyte to recover from bed-moving floods in Ozark streams. So that's super cool. Overall, we did have 3 study questions, and it's if biomass is allocated differently between roots, shoots, and rhizomes, if there is a difference in available macronutrients in the streams, and if it's correlated with abundance in biomass. And also the last question is if stream bed substrate size and embeddedness is correlated with rhizomatous growth. So one of the coolest things about our study is we chose 6 streams across a land use gradient to see if water willow would grow in any of them at all, and if it would grow differently between them. So we first started in March and we collected 20 centimeters of rhizome with a growing meristem to be able to measure the biomass. So if you look on the left side, there are 2 little figures with pie charts. So the top one is the biomass allocation from March 2022, and the bottom is the biomass allocation from April 2022. Each of them are separated by fibrous root, rhizome, and shoot. And we only collected from 3 sites, Bull Creek, Goose Creek, and Pomme de Terre, because that was all we detected at those specific stream sites at that specific time. But hopefully, as we continue, we will find water willow in all 6 sites. So we also collected water samples, and this time we collected water samples to measure nitrate and phosphate, and we were able to collect from all 6 sites. If you look in that table in the middle in the nutrients column, you can see the P's and the N's. So the P is for phosphate and the N is for nitrate. And most of them are the same size, but if you notice Panther Creek, it's the 3rd one down, it has a higher P because it has a higher phosphate availability. Same with Goose Creek and Pickerel Creek, they have bigger N's because they have a little bit bigger nitrate availability. So that's really cool, and I can't wait to see where that kind of goes as the growing season continues. Now, one thing we haven't gotten to, but we will get to, is measuring the sediment size and the embeddedness, and if it's correlated with rhizomatous growth at all. We will be doing this in the future, probably over summer as the water willow shoots mature, to really get a good answer on that one. But we do hypothesize that rhizomatous growth increases fine sediments and increases local habitat stability and even complexity. But overall, we want to know, so is water willow a driver of the stream? Is it an ecosystem engineer? Does it modify its habitat significantly enough to be termed that? Or is it a passenger? Is it controlled by its nutrient status? Or maybe there are other factors that it's controlled by. But hopefully we can get the answers to those questions as the year continues. And I'm very excited to see where this goes. And it's really awesome. So thank you so much for listening, and we'll see you soon.